And to keep your attention span alive, I picked 3 buzzwords: container-based microservices in the cloud. Maybe 3 topics which the last year you have not read enough articles about and saw enough presentations. What I'm going to explain, I'm not so much going to give a recap of the article we have submitted or going into the details of Docker, container, cloud, microservices, because I think other people can do that better than me, and it has been done. So I want to give you a brief overview why we chose the topic, how we chose it, and what has been our experience while working with this. Short background, I don't want to sell us or our 6-digit salaries, but we are a development company based in Germany with offices in Romania, in Moldavia, in Ukraine, Switzerland and USA. And we are working in the area of VOD and IPTV and OTT. So our customers typically are broadcasters, operators, channels, content owners who want to stream their content, similar to Netflix or others, Amazon Prime, which are not our customers, unfortunately. But this explains a bit what we are doing and why we are doing it. And the article was done by 3 people, my colleagues, Jordan Oseboti and me. And unfortunately the font seems to be a bit stretched here, but either way I think the important part is the diagram. So we have started to work on this topic probably 1.5 years ago, when our company decided to switch a bit from custom development to developing a product, and this product needed a backend. And then back then we had some experience, started with Docker, started with the very early versions of Kubernetes, and we said, okay, we seem to be experts, let's just do it. And as it happens, if you know how to work with new technologies, the point where we thought we are experts, we probably have been here. And throughout the last 1.5 years, we gradually moved to the right. I think we made it through the realistic valley and are not yet on the top right, but on the way, maybe. So why we need these microservices? Again, I think microservices have been explained over and over, but to give some context on what we do, so our backend needs to communicate with a lot of other backends. So our customers usually have 2, 3, or 4 different systems from different vendors. Some of them are 10 years old, some of them are pretty new, so there is no common way of communicating. And on the other hand, on the lower, in the right corners, our business, again, it's about streaming. We are working in the multi-screen environment, which means our customers need tablet, iPhone, iPad, web, smart TVs, game consoles, whatever you can imagine where you can have video, they want to have it. And all those clients need to talk to backend on the top. And this is something, if you want to do this work on each and every client, you will have to implement 4 to 5 backends for every client, multiplied by every customer. Then you end up with 20, 30, 40, 50 different implementations you need to do, and this kills you over time. So we decided, okay, let's be clever, put something in between. We call it a mediation layer, which is kind of just taking the APIs from the source, translating them into what we expect, and making sure that which backend ever we connect to our clients on the bottom, we use the same API definitions, we use the same metadata structure, and we use the same format, which means if we want to develop tomorrow maybe a new client on a Samsung TV or on an Xbox, we already know how the APIs will look like. They're exactly the same as on any other client. And in the same way, if our vendor at one day decides maybe to switch the recommendation engine or to switch the billing system, we don't care, because we have to do the implementation only one time in the mediation layer instead of 15 times in every client. So that was the motivation, and this defined a bit what we wanted to do and how we want to do it. And in a nutshell, what we needed to achieve is, of course, we want to deploy anywhere, because some customers wanted to use Amazon, others use Google Cloud, others have their own data centers, so everybody wants to have something special. Again, replacing of components is important, because they usually switch the vendors wherever it's the cheapest, so that might happen that tomorrow the billing system gets changed and you need to react. We did not want to stick to one technology. If you read the article, then you see that, of course, like a few other people, we build everything with Node.js right now. But we have a lot of different requirements, and we are sure that at one point Node will not be the way to go. Maybe we need to use Python, Java or something else, and then we want to change this for one service or for a part of a service without having impact on anything else. So we want to isolate the environments and the technologies. Yeah, of course we want to maintain and develop with small teams because we are a product team in a development company, so we can't choose to have 50 resources working on it, and requirements in customer-driven projects come in every other day. And very important for us, we want to scale with our customers because unfortunately not everybody of our customers is the next Netflix. Usually they start very small and then they take off, but they don't know yet when, so it's gradually increasing the total numbers of subscribers, but also the usage pattern. So especially in the TV area and in the VOD area, you have like bumps on a Sunday evening or a Saturday evening, and the rest of the week you have hardly anything. Yeah? This is why you need to have a system which can just scale on a Sunday evening, and then on Monday to Friday again it costs you hardly any money. Yeah, how did we get there? I think the first point was, I think the biggest one for us, we did a lot of trial and error because we started, we had knowledge, we thought we were experts, and then when we tried to migrate what we had on our local development environments where Kubernetes, Docker, everything was working great, we deployed it and nothing worked. We lost the engine, Docker containers were missing, were restarting, they were not found anymore, data was lost, anything went wrong, and we had to figure out on the hard way how to get there. Yeah, we use microservices to develop the individual services, so we have a system which splits the functionality between subscription, payment, authentication, search, profile management, everything. And each of these services is deployed in a separate container in our Kubernetes cluster. We built a semi-automated built-in deployment system, so we managed so far quite nice to get our Docker containers built with GitLab CI and to get them pushed into our own repositories and pull them from there again. We did not do it fully automated. First, we still have some issues to solve. On the other hand, we also wanted to keep the control when we are releasing, because even though we do tests and everything, not everything which gets pushed should be deployed automatically. And then, yes, one of the biggest challenges we had to solve while doing this is, since we are talking about maybe 20 services, if it would be just for one customer, already 3 environments, daily, staging, production, then the services are on host, so we had like 50, 60 systems which we needed to monitor to see, are they working, what are the services doing. So what we built a system with Elastic, Logstash and Kibana, where we use FileBeat to monitor the log files on the systems itself, on the hosts. We use a system to get the standard out logs from the different services and send them over to our Elastic index, and have built us a nice small dashboard in Elastic where we can watch then all the status of services, hosts and our cluster, which also helps us to correlate performance data of the system with the usage pattern. So we can see then if requests are getting slow and usage is going down because requests are getting slower. Yeah, our setup, I mentioned it already, so you find the usual suspects. We use Docker, we use Kubernetes. We tried at the beginning to use Ranger. In the development environment, this also works fine for us, but then in the production environment, it was hardly usable for us anymore, because as any system which adds UI features, usually it takes away a lot of control, and then if things go wrong, you're lost. We use Google Cloud, not because we think it's such a great thing, but for us the cost was also very important. And since we're just using CPU, we're using the Kubernetes cluster and RAM, and this was for us way cheaper on Google than on Amazon. And also the Kubernetes integration on Google Cloud turned out to be pretty nice for us. So it works with hardly any efforts. We can just deploy our containers in, and it does everything for us. On top, we use Nginx for the internal routing in our services. So this is everything behind the public ports is done then through the Nginx. And on top of this, we have the Google Cloud Load Balancer, which just distributes the traffic. And yeah, Node.js, you've seen it probably already, some very used for developing the services at the moment. So if you're not so familiar with how containers work compared to virtual machines, a small diagram just to explain very briefly from where we went to which state. On the left, this is what we did in the past, and how you do it usually without containers. So you have probably some kind of virtual environment where you have a hypervisor which has different machines installed. Each of them has a guest OS, but they're kind of replicating or simulating a complete machine with CPU, hard disk, GPU, everything you want. And then you deploy probably your full application in there or different applications and consume them from there. And with switching to containers instead, we now have still a host OS. I'll be finished soon. We have instead of having really different virtual machines, you have those different Docker images which are executed by the Docker engine and shares the resources of the host system with the different images and the different containers you execute. So you don't have a fully virtualized environment. Instead, you just pick what you need. And since you're deploying small containers and you don't have to put in a full OS, you don't have the full dependencies, you can really just put in what you want. We, for example, right now use Alpine Linux because it's very small and it has all the dependencies we need to get Node.js running. So we have a OS which is probably 15 to 20 megabytes if it's much. And then we have our services. So we have very, very small images which are, I don't know, below 100 megabyte, far below 100 megabyte. How this looks a bit closer. So I put here two names of our services to illustrate it even more. The rest of the image is exactly the same, just with more zoom. So everything which we deploy contains of the Docker file. I assume that most of you have heard me about this. So the Docker file in the Docker environment is something which describes with a base image which steps need to be executed until the container is running and is usable. In there, usually what we do is we spawn our services, we assign a port. We use a lot of environmental variables because if we want to deploy the same service on different machines for different customers in different environments, we just pass the client ID or maybe the environment or also the port through environment variables into the configuration of the Docker file so that we don't even have to touch anything. So for us, it's exactly the same file that gets deployed on staging or on production for customer A or B. And just through the Kubernetes configuration, we change the environment variables which are getting passed there. This also works even with tokens we need to give there or secrets. We all just pass them on there and we don't have to touch any configuration. And then of course with the switch to Google Cloud Engine, we got also rid of the layer with the Docker engine, so we don't have to care about this because once we deploy our containers to Google Cloud, they take care of all this and to the Kubernetes orchestration. And in the end, if you want to have it very, very simplified and just a fraction of the things which we have deployed right now, it looks in the end exactly like I tried to explain. On the very left, we have our various clients, some of them web-based, a lot of them are native clients, iOS, iPad, iPhone, iPad, whatever. They communicate only with the Google Load Balancer. This is the static IP, which also does the SSL termination. And from there, then we have everything as normal traffic on port 80 routed through different Nginx, which just see based on the routing which service actually is required. Move forward to our services, which are then deployed in individual service nodes on Kubernetes. And Kubernetes takes care of the scaling by spawning endpods for each service depending on the traffic. What we have added now, we use labels for our service nodes and our services. So we have each service labeled for a certain purpose. So for example, one service node for authentication, another one maybe for profile management, and the same for the services. And Kubernetes then does the scaling based on those labels. So if it sees that the profile service needs another pod, it just goes into a service node labeled for profile service and spawns a pod in there. And this is actually the part which took us very long to get there because we started also when Kubernetes was maybe not yet stable enough, or it was maybe stable but not easy enough for us to understand everything. So we had here, this was the step where we had a lot of trial and error to really get to the right setup. Because also one of the issues which has been solved now just last week is that you don't have any disk persistence in all this. So whenever something was crashed or restarted, you lost everything which you had written to any disks. So and you couldn't just scale up the disks. So we had also had issues where log files were just we had a lot of log files, and they were just populating every space we had on those services, and we couldn't get any new space in that. These were all the small issues which, of course, every week a new one appeared and we had to solve. Our CI pipeline is also very, very simple. We use GitLab CI. Then we are building the Docker image in that GitLab CI, so with every merge which gets done from the feature branch into our development branch, automatically triggers a very, very small shell script which builds a Docker image. In the end, it's only 5 lines meanwhile, but to get to those 5 lines was another 5 months because sometimes the runners were updated and the shell commands didn't work anymore. At the beginning, we wanted to do everything with Docker, and maybe you know that there is the mode to have Docker inside Docker running, which sounds great, but for us at least never worked, so we switched back to shell runners and had to try there. We use Nexus repository as our registry for the Docker containers, so once the build is done, they get pushed to the Nexus repository, and on the other hand, on the environments, we have very, very simple shell scripts, which again, when we want to make a deployment for a certain stage, we just pull the images, pass them out to Kubernetes, and let it do what it needs to do. What we learned, a lot of things, unfortunately, or fortunately. So most importantly, it's not just a development job, especially in the second half of the no project duration. I think half of the work was actually more DevOps deployment and trying to figure out how to work with Kubernetes and the environments around that, and less developing the services. We took a lot of time at the beginning to find the right setup. We switched the host OS, we switched the OS into containers. A lot of times we switched from Ranger to Kubernetes back, and then back again to Kubernetes. As everybody in this room probably knows, new stacks come with a lot of risks, especially at the beginning. The admin UI, which was released for Kubernetes, lacked some features, had some bugs, and they just made a major upgrade, which broke some things we used, and we didn't figure out what the issue was. So these are all things which hit you if you are or try to be an early adapter. Another thing, with the huge amount of releases we need to do, because we have about 20 services which need to be deployed, it pretty much turned out if you really do not organize this well and you don't have a clean process, you will run into issues because you lose the overview for every team member, which environment has actually which status, what is working, what is not working. And another thing we also learned, even though we have this fantastic CI pipeline and we can build the images and we can deploy them, it still is better to double check it on 2 environments and to make only releases when we really need them. Because of course our product team then thought, great, now everything is set up, so if we want to change 1 line here and 1 line there, let's just make a deployment. And at the beginning we tried to be cool and go with it, and it broke every other day because the whole process just to build an image simply already takes some time, and then even though you can make updates for every line, you waste 1 hour to just deploy through all the stages, then to test it again, and then half a day is gone if you want to just maybe fix 1 line of code or improve it. The next steps. So what we did not yet do to the full extent is inter-service communication with our services. We just started with this. We need to optimize the setup for the cloud, mostly regarding cost effectiveness. We rather went to the higher end of things we need, and we now need to slightly scale down and see how much we can reduce without having an impact on performance. Disk persistence, I just mentioned it, actually this was now solved with stateful replica sets, which have now just been made available. So we're trying to switch to that, and this seems to solve the issue for us. The caching implementation, we went the easy route and we just use Nginx right now, which works very good, but is probably still not the best solution you can get, so we want to improve this part as well. And of course we want to go from semi-automated to fully automated with the according security measures. It just goes into a service node label for profile service and spawns the code in there. And this is actually the part which took us very long to get there, because we started also when Kubernetes was maybe not yet stable enough, or it was maybe stable but not easy enough for us to understand everything. So we had here, this was the step where we had a lot of trial and error to really get to the right setup, because also one of the issues which has been solved now just last week,
is that you don't have any disk persistence in all this. So whenever something was crashed or restarted, you lost everything which you had written to any disks. So you couldn't just scale up the disks. So we had also had issues where log files were just we had a lot of log files and they were just populating every space we had on those services, and we couldn't get any new space in that. These were all the small issues which, of course, every week a new one appeared and we had to solve. Our CI pipeline is also very, very simple. We use GitLab CI. Then we are building the Docker image in GitLab CI, so with every merge which gets done from a feature branch into our development branch, automatically triggers a very, very small shell script which builds a Docker image. In the end, it's only 5 lines meanwhile, but to get to those 5 lines was another 5 months because sometimes the runners were updated and the shell commands didn't work anymore. At the beginning, we want to do everything with Docker, and maybe you know that there's the mode to have Docker inside Docker running, which sounds great, but for us at least never worked, so we switched back to shell runners and had to run there. We use Nexus repository as our registry for the Docker containers. So once the build is done, they get pushed to the Nexus repository, and on the other hand, on the environments, we have very, very simple shell scripts, which again, when we want to make a deployment for a certain stage, we just pull the images, pass them out to Kubernetes, and let it do what it needs to do. What we learned, a lot of things, unfortunately, or fortunately. So most importantly, it's not just a development job, especially in the second half of the no project duration. I think half of the work was actually more DevOps deployment and trying to figure out how to work with Kubernetes and the environments around that, and less developing the services. We took a lot of time at the beginning to find the right setup. We switched the host OS, we switched the OS into containers. A lot of times we switched from Ranger to Kubernetes back, and then back again to Kubernetes. As everybody in this room probably knows, new stacks come with a lot of risks, especially at the beginning. The admin UI, which was released for Kubernetes, lacked some features, had some bugs, and they just made a major upgrade, which broke some things we used, and we didn't figure out what the issue was. So these are all things which hit you if you are or try to be an early adopter. Another thing, with the huge amount of releases we need to do, because we have about 20 services which need to be deployed, it pretty much turned out if you really do not organize this well and you don't have a clean process, you will run into issues, because you lose the overview for every team member, which environment has actually which status, what is working, what is not working. And another thing we also learned, even though we have this fantastic CI pipeline and we can build the images and we can deploy them, it still is better to double check it on 2 environments and to make only releases when you really need them. Because of course our product team then thought, great, now everything is set up, so if we want to change one line here and one line there, let's just make a deployment. And at the beginning we tried to be cool and go with it, and it broke every other day, because the whole process just to build an image simply already takes some time, and then even though you can make updates for every line, you waste 1 hour to just deploy throughout the stages, then to test it again, and then half a day is gone if you want to just maybe fix 1 line of code or improve it. The next steps. So what we did not yet do to the full extent is inter-service communication with our services. We just started with this. We need to optimize the setup for the cloud, mostly regarding cost effectiveness. We rather went to the higher end of things we need, and we now need to slightly scale down and see how much we can reduce without having an impact on performance. Disk persistence, I just mentioned it, actually this was now solved with stateful replica sets, which have now just been made available. So we're trying to switch to that, and this seems to solve the issue for us. The caching implementation, we went the easy route and we just use Nginx right now, which works very good, but is probably still not the best solution we can get, so we want to improve this part as well. And of course we want to go from semi-automated to fully automated with the according security measures to not destroy our environments. I thank you for sticking with me even though the food is outside. If you have any questions.
You are very fast in talking. So.
I was waiting for so long and then.
Okay, we have a question here.
Hello. What are your advices for choosing a container orchestration tool, and why use Kubernetes over Docker Swarm or other options? I think based on your experience.
So we had a customer project where the customer demanded to use Kubernetes. So we got that experience with this before we used our own product. Then we, as I said, we wanted to use Ranger because we looked at them and Ranger looked more appealing for us in the easy use cases. But then it added so much overhead with their own tools, with their own command line client, and all this abstraction, which didn't work for us. And when we started it, Docker Swarm, at least in our opinion, was still not on the same level as Kubernetes. And then we just say, okay, in Germany say, the cow shits on the biggest dump, yeah? So let's go with Kubernetes. They have the biggest company behind. They seem to know what they do. Yeah.
So Kubernetes instantiates your microservice, right? So this is what actually does. So instantiates all the creates instances for all your microservices.
Yes.
Does it provide some
failure propagation, like reactors in Akka or Urban do? And what happens if a microservice crashes?
It just starts a new one. So
Is the error propagated somehow?
So they have the notifications, yeah, but we just completely ignore that, we log that, and we just wait for the next one to come up. So we also don't have any dependencies in the services if they crash.
So you assume that if it crashes, you don't care about the error?
No. We look at it later on.
Yeah, luck-oriented development.
Okay. But this is probably also one of the parts where we still can learn a lot.
I know the advantages of using containers, but could you tell me how is the performance? I'm thinking that all these applications, all these containers being on there in a virtual space, isn't affecting performance somehow? What would you tell me about your experience with this?
So in the cases where we compare it, there's absolutely no loss. It's even better because so before that we had like still also virtual machines. So I mean we deployed them, for example, with Veeam or something. We had our OS set up and had the services in there.
Okay, so still virtual machines before. Okay.
Yeah, so
then
I don't have the comparison to really have complete hardware there. But again, I mean, even if I really can't give any metrics on that, but simply the fact that we can just anyway replicate it, and we do a lot of I/O, so there's not a lot of processing we do, right? We take an API response, we transform it, best case we cache it, and we pass it through. So we don't really use a lot of CPU to do anything besides this. And for that, we can just scale with the amount of instances. And then there's no way that dedicated hardware could compete with that, for our case at least.
Thank you.
Okay, thank you, Stefan. He will be also with us tomorrow in Târgu Mureș, so if anyone wants to come in Târgu Mureș to lunch event there, then you can come. Sorry?
Then also some developers will be with me.
Okay.
Who can explain more detailed questions probably.
Okay, thanks.